Hello guys, welcome back. On Dev Day, OpenAI introduced some new features and let's go through that functionalities with LangChain. I have already created a video about Open Assistant, how you can use that without writing a single line of code. And then I have also shown you how you can create the OpenAI assistant using Llama Index. But some of you mentioned in the comment section that is it possible to do the same thing with LangChain? Here you go. We'll be exploring different functionalities. How the video will proceed is first we'll install libraries and set up the environment, and then we'll go through the new vision model, how we can let's say give an image and then get the information out of it. And then I will show you OpenAI assistant features. There were code interpreter, there is a retrieval, and there were also the tools, how we can use or provide different tools. That one will go through the custom tools also. Let's say how to use a LangChain agent with the arbitrary tools also. And at last, I will show you the JSON mode as well as some other extra functionalities. Let's get started. Okay, first thing first, we need to install libraries and environment set. By the way, I will provide the Google Colab notebook in the description of the video so you can follow along with me. Let me expand this one. I have already installed this. What you need to do is just run this shell here. And then I'm using this watermark package in order to display what versions of packages I'm using and what is the different OS and processor CPU cores, how many I'm using, so that you know what kind of machine is needed in order to run this. Or if you are using Google Colab, it's the same for most of us, right? This is the free version of the Google Colab. And then next we need to import the OpenAI API key. Please go to this platform. If you don't have the account, you need to create the account. This is not free. You need to provide the credit card and get access there first. Replace this with your API keys. Once that is done, we are ready to go. Now let's go to the vision model first. What is the vision model? Let's expand this. You can click this and it will take you to the documentation. But OpenAI released the multimodal models which can take a sequence of text and images as the input, right? Until now, we have this, we provide the natural language text, and then it also produces the text out of it. But with the help of these multimodal models, we can also pass the images so that we get the information of the images. Just to show you, let me just show you one image here. This image is just from the documentation of LangChain, which shows the overall, let's say, architecture of LangChain and what it provides, right? Here is the protocol, there is the integrations and components, there is the application, deployment, and then there is LangSmith for the traces and things. But let's say what the model provides us just by passing through this image, right? What we can do for that is we first import the chat OpenAI, and this is just the normal import things that we do. And here what I am providing is this model here, GPT-4 Vision Preview. When you are using, depends if there is the updated version of this or not. But at the time of this recording, we need to provide GPT-4 Vision Preview. And the maximum number of tokens, you can just play around with this. Here we are saying chat.invoke and we are just passing these different things here. Right? I'm just passing the same URL which I showed you to display here. Let's see what it provides us when we run this particular thing. Okay, it says it's not defined, so meaning that I didn't import this one. I will import this first and then run this. It is going through the API and then it's going through this particular image, and it is going to provide us what that particular image is all about, right? Just by seeing us, we know that there are different components there, but for multimodal things, it needs to go through this image and get information out of it. Okay, this image appears to be a diagram or a graphical representation of a software stack or a platform architecture, possibly for a language processing or language service system, as indicated by terms like LangSmith, LangSorb, and LangChain, right? And here is the breakdown. It also goes through different things. This is likely a component or layer. As you can see here, it grabs all the different components that we have here, and then it provides us the answer what it says in the image. So it's quite impressive already that we can provide the image and it gets the answer out of it. You can just play around with this, and this is really good because I have already created the video before also, because in documents you have image, also you have text, you have tables, right? And you also want to extract the information out of images for a better retrieval. This is really good approach here. And just play around with this. Now let's go through the OpenAI assistants. I'm not going to go through the in details about what is this, because I have already created the video about that. But here it says that the assistants API currently supports code interpreter, retrieval, and the function calling. Let's go through that, right? First, we'll be using only the OpenAI tools. What I'm doing here is from LangChain agents.openai assistant, we are importing the OpenAI assistant runnable. Let's import this one. And if you want to know the code, you can just uncomment this and run the cell so that it shows you the code written, so you know what are the different parameters or arguments that you need to pass. Now let's first go through the code interpreter example. What I'm doing here is interpret assistant, and I'm just using the class that I just imported and dot create assistant, right? And then I'm giving the name, instructions, tools. In the tools, I am using the code interpreter for this one. And you need to be careful now with this model here. We are using GPT-4 11.6 preview, but in the Vision one, we were using Vision preview. But here we are using this GPT-4 11.6 preview. 11.6 meaning that it was released on the November 6th. What we can do now is I can say, okay, I need to solve the equation 3x plus 11 equals to 14. Can you help me with this? If I run this one, so it is going through that new model and it will be running the code interpreter behind the scene. And then it will be stored in this output variable. And what we can do here is print that. Yeah, when I print this, as you can see here, it goes through this particular model and it's okay to solve the equation this, we need to subtract 11 from both sides of the equation and all the different things. And here you get the answer. It says here, okay, the solution of the equation is x equals to 1. You can format this and just get the right answer for you, but you get the idea how it is shown here. Answer is 1. The good part here is that there is this run ID and thread ID things. So I will show you later how we can implement this, because what you can do is basically provide the previous thread ID in the existing one to just get the answers from both of that. I will show you the example of that later. Okay, so that is the code interpreter, right? Now let's go with the retrieval. If you have followed my videos earlier, we are doing lots of RAG implementations, because that's what we need to do, because we have documents, we want the answer out of it. That's what the retrieval augmented generation means, RAGs, right? That is now by default supported by OpenAI Assistant. Let's just go through here. There is example of retrieval. There might be many ways how you can achieve this, but what I just went through is taking some example from the OpenAI documentation itself, and then there is already a way how you can invoke this with the LangChain. Here I'm just saying the from OpenAI import OpenAI client equals to client, because that's the default client. I just use this so that I can create, or let's say upload the file, right? Here I'm first using GPT for all paper. What I did here is I uploaded a GPT for all paper already here in the PDF. I just take the path of this particular file. Then what I did here is I open this and then just client.files.create. Why I created this file is that I can then pass that ID of the file into the LLM, let's say assistant, in order to get the answer. Here is interpreter assistant, but what we can name this is retrieval assistant, and then we can run this. We have retrieval assistant, we use the same class, and by the way, what the tools is now the retrieval, right? And we give the instruction, answer the question based on the context provided, and we use the same model. Now what I can do here is use the retrieval assistant instead of the interpreter assistant. What I am passing here, this is, by the way, it took me some time to figure out how to pass the file IDs, because in Llama Index we used to pass already when we create the instance, but here it is when we invoke it, right? There might be many ways, but this is how I got it working. Let's go through that. Here I'm storing the answer in a output variable. A retrieval assistant, this is what I just created, and dot invoke, and say I am saying here who are the authors of the paper. Of what paper? Because we haven't provided the paper, meaning that we haven't provided the file yet from where it gets the information, right? Here I'm saying file IDs and I'm passing the file that we have created here. Just to show you how it looks like, I can just go here and type file.id. So it has some ID related to that file. I'm just passing the file here, right? Let me run this one. What it does now is, yeah, the same thing, but now it is using the retrieval instead of code interpreter. And then it is going to store the answer in the output variable. What we can do now is just print the output. So it will take some time. Okay, now it's completed. Now what we can do is just print that output, right? When I print the output, as you can see here, it provides me the answer, but it's not formatted well, right? What we can do is then just use regular expression to extract just the answer, the value that we want, right? With just this piece of code, what we can do now is get the right answer. The authors of the paper are, and then it gives all the name. They are affiliated with this. Yeah, this is how you can format the answer that we get out of the large language model. That's that easy. We don't need to write all the different things from, because by default it is using the OpenAI's models and the embeddings of OpenAI, but you don't need to go through all the loop, right? We don't need to specify, okay, chunk the file. We don't need to embed the file. We don't need to store that into the vector store and then retrieve the answer out of it, do the similarity sorts and all the different. It is doing all the things behind the scene. This is quite impressive, and it's really good to see that how it is evolved. By the way, you can use different things or different models using LangChain, but by default, OpenAI Assistant is quite powerful, and there are many experiments done by many people that, okay, is it really good that it is providing the answer or not? For that, I leave all up to you. You just test and try different things. Let's try with LangChain, with different these RAG implementations. You can try with this, let's say, fast approach and just see the answer out of it. Now, what we can do next is we can just go through the next part, that is as a LangChain agent with arbitrary tools. Now we use the tools that is provided by OpenAI itself, right? We use the tools like Retrieval, code interpreter, and so on. What if we want to use some extra tools that we want ourselves, right? Let's do that. Some examples here. Now let's create the functionality using our own tools. For this, I'm taking the example from LangChain documentations. They are using this E2B sandbox runtime. What you need to do if you want to go through this process is go here and create the account. And once you create the account, you can use it for free also. And there will be a API key being shown here. You can just take the API keys. Let's go to the code. You need to first install E2B and then the DuckDuckGo sorts, because we are going to source through the internet also. And then you need to pass the API key here from that website and then just run this one. I have already run this, so I will not run it again. But then, yeah, the same things here. We create the agent, and now we give some name. Here is the instructions. There's the tools that we just created here. We are passing two different tools at the same time. And now we are using this new model, and we say as agent equals to true. Yeah, just few lines of code. It is taking now our customized tools. By the way, you can use as many tools as you want here, provided by the LangChain. Yeah, now we need to using the agent executor. In LangChain, there is a thing called agent executor. What we do here is import that first, and then we pass the agent and the tools into the agent executor. That's how things are done. And then we can ask the question, what's the weather in Helsinki today divided by 2? If I run this now, it is going to use these particular tools as well as the agent and provide the answer for us. Let's see what the answer it will provide here. And by default, it provides the answer in Fahrenheit. As you can see here, okay, what's the weather of Helsinki in Helsinki today? It's based on the source regions. The current temperature in Helsinki today is 45 degrees Fahrenheit. I am not that good with Fahrenheit. I am good with Celsius, and it's easy for me. What I can do here is, okay, what's the weather in Helsinki today in Celsius divided by 2? Yeah, this is just the simple prompt or content you can provide to LLMs. It's easier and you can customize based on your use cases. So yeah, let's see what it will provide for us. Okay, this is the response, but we need to print the response, right? Let me create a new shell here, and then I can just say here print response. So yeah, what's the weather? And by the way, I can even do this p print, so it shows us good formatting here. Okay, what's the weather in Helsinki? Okay, the weather today in Helsinki is -2 degrees, and to find the value of -2 divided by 2, we can simply perform the division. So it shows here that for the temperature is -1. Yeah, and then as you can see here, there is this run ID as well as a thread ID, which we get when we pass these new models with it using these executor kind of things. I hope you get the idea how we are dealing with our custom tools also. Now let's say that we want to do some custom execution, right? We define a function to execute an agent using a set of tools and an input. This is just the function we are using here. You can just go through this function, and this is helpful because with the help of this we can pass the thread ID into the next round also to get the let's say to combine the answer. All the comments are written here. I'm not going to go through the code, but you get the idea that what is happening here, right? We can just run this function. Once that is done, we now say the question execute agent, because this is the function name that we created. And then what we do, we pass the agent, we pass the tools, and then also we need to pass the input content, right? I need to solve the equation 3x plus 11 equals to 14. Can you help me with that? And let's just pass this, what it is going to do. This is how you can customize the things also based on your use cases, right? Custom execution is what you need to do in different applications, because not all the applications might need the same way of prompting and using things, right? You different applications, you can create the custom execution. So yeah, here as you can see here, what it is doing is, okay, E2B data analysis, it shows here which tool it is using, right? Because this is what we are just printing here, print as you go, right? It shows here that we are using E2B data analysis, Python code defining this. As you can see, the equation, this can be solved by following these steps. It's a subtract 11 from both sides, and these all the things, divide both sides by 3, and the answer is 1. It gets the answer 1, right? And now it is stored in this response variable. What we can do now is passing the earlier thread to the next response. Next response is execute the agent, same function that we created. We pass the agent, we pass the tools, and we said here, okay, now add 2.241, and we pass the thread ID, and the thread ID is the response dot thread. If I just show you here, if I just show you response dot thread ID, right? Thread underscore ID, there is some ID associated with it. What we do here is we just pass that. So answer must be 1 plus 2.241, right? If we run this one, let's see what will be the answer, because that's what we have instructed here. Now add. So as you can see here, it is now again going to the E2B data analysis. After adding 2.241 to the solution of the equation, the new solution is 3.241. This is a really good way how you can build your applications, right? You don't always hard code things. You need to get some information from some places, and then you need to pass into the different function and so on. This is the good way how you can deal with the thread ID also, and then create application. Okay, that's good. Another thing, a really interesting thing that came is the JSON mode. You can go through this link, but what it is constrain the model to only generate the valid JSON. That's what we can do now with the help of this updated model. What it's here, we are just creating the chat OpenAI. We are using the model here. We are using GPT 3.5 Turbo, and we can just bind, and here you can say JSON object. What we want from here is, let's say that we have the system message, extract the name and origin of any companies mentioned in the following statement, return or JSON list, right? And the human message is Google was founded in the USA while DeepMind was founded in the UK. It needs to go through this particular content and find the name and the origin of any companies. Yeah, let's run this. This is how, yeah, it shows here the companies, name, origin, name, origin. Now you imagine that how powerful it is when you create the applications, because JSON is really cool and you can manipulate it according to your use cases, and it would be a really good use case, not use case, but it will be a really good tool to have when you create the LLM applications. Now let's go to the last one with the tools. Why tools? Tools meaning that we can use the tools for parallel function calling. That is another good thing that OpenAI introduced in the DevDay, right? We can use, before there was the function calling, but you need to invoke the function once and you get the output. You need to invoke again the next one, meaning that there were multiple calls to the model. But now what we can do is with one go, you can call the multiple functions. You can have many functions, and in the LLM applications, it's obvious that you will have many functions, right? You can do parallel function calling. So yeah, what we are doing here is just importing the normal things, and we are using pydantic here, current weather, get the current weather in a location. By the way, there isn't any API key being provided here. It does not provide us actual weather, but just to show you how it works, we are saying here, okay, location, field description, the country, the city and the country, let's say the Kathmandu, and the country is NPL, meaning the Nepal. We said here default Celsius, description, the temperature unit, default to Celsius. So here is the prompt. What we are doing here is creating the prompt first. Chat prompt template from message, and we are saying you are a helpful assistant. You can just provide what you want. And the model is chat OpenAI. We are using GPT 3.5 Turbo. Bind, and we are using the tools. Tools is convert pydantic to OpenAI tools, and we are passing this particular class here. And now we are using the LangChain expression language here. I hope you know already what is LangChain expression language, or if not also, it's okay. You can just go through the documentation. It's a new way how you can, let's say, chain different things with just one line of code. Here it is chain, and we are passing the prompt, model, and the pydantic tool parser, and we are passing the tools as current weather, right? Get current weather, and we say chain.invoke input. What's the weather in KTM, SF, and Helsinki, right? When I run this one, so it will go through each and every line, and you can see here it is running here. Okay, get current weather, location Kathmandu NPL, San Francisco US, Helsinki Finland. This is how it is showing, and you can use the same concept when you create the applications. Okay, that's all I want to show you, and you can just play around with this. But the good part is whatever I was running here, that is being, most of those are being logged in the OpenAI's assistant. Just to show you, this is the assistant, right? I will refresh the page. As you can see here, there are different things I run just now. There is LangChain assistant. There is LangChain OpenAI retrieval that I just wrote, right? If I go inside here, as you can see here, this is the answer the question based on the context, and we are using the retrieval, and that's how it is shown here. Everything that you use is being shown here. There is this assistant E to B tool. If you just click here, as you can see here, it shows what it is here, and we are using two different functions, right? E2B data analysis and doc go sorts. If you don't know what it is behind the scene, the function, you can just click here. As you can see, it says name, description, parameters, and all the different things. We don't need to write that because it is by default taken care behind the scene, but you get the idea that we can quickly run your applications and then quickly see that also in the assistant UI provided by OpenAI. Yeah, I hope you learned something new, and now you can quickly integrate the new features provided by OpenAI in your applications using LangChain. Yeah, thank you for watching, and see you in the next video.